Hello friends, my name is Ramasu. Today we shall discuss about topic the support vector machine algorithm. Friend, today's topic is very interesting, especially if you have interest in machine learning or artificial intelligence, or you want to learn about it. So let's start, friend. First of all, I would request to please subscribe to my YouTube channel and click on the bell option as well, so that my new videos can reach to you, and also you can follow me on the Facebook page as well. Friends, support vector machine or SVM is one of the most popular supervised learning algorithm which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. So one by one we shall discuss it in detail. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. This best decision boundary is called as hyperplane. SVM chooses the extreme points or vectors that help in creating the hyperplane. These extreme cases are called support vectors, and hence algorithm is termed as support vector machine. Consider this diagram in which there are two different categories that are classified using a decision boundary or the hyperplane. SVM can be understood with the example that we have that we can use for classification. Suppose we see a strange cat that has some features of dogs. Okay, for example here. So so if we want a model that can accurately identify whether it is a cat or dog, so such a model can be created by using the SVM algorithm. We will first train our model with lots of images of cats and dogs so that it can learn about different features of cats and dogs, and then we test it with this strange creature. So as support vector creates a decision boundary between these two data, cat and dog, and choose extreme case support vectors. It will see the extreme case of cat and dog. On the basis of the support vector, it will classify it as a cat. For example, this is the past data with like cat and dog, it already there. This is the model training, and then on the prediction we received the new data from here. Okay, so because it's a new data, so we have to think that whether it is a cat or whether it is a dog. So by using the past data and by using the algorithm, we identify that this is the output as a cat, and it will separate this new data from this this data and from this data. Okay, now how does SVM actually works? We have to think, we have to analyze it in detail. For example, from the data points or vectors that are closest to the hyperplane. Hyperplane is the line which separate the two data and which affect the position of the hyperplane are termed as support vectors. Since these vectors support the hyperplane, hence called a support vector. The working of the SVM algorithm can be understood by using an example. Suppose we have a data set that has two tags, green and blue. Okay, and the data set has two features, x1 and x2. We want a classifier that can classify the pair x1 x2 of coordinates in either green or blue. Now what we would do, like so it is a two-dimensional space, so by just using a straight line we can easily separate these two classes, but there can be multiple lines that can separate these two classes. Okay, so what we will do in that case, the SVM algorithm helps to find the best line or decision boundary. The best boundary or region is called a hyperplane actually. Okay, so hyperplane to identify, so SVM algorithm finds the closest point of the lines from both the classes. These points are called support vectors, and the distance between the vectors and the hyperplane is called a margin, and the goal of the SVM is to maximize this margin. The hyperplane with maximum margin is called a optimal hyperplane. So friend, I hope you like this video. If you like it, please share it with the friends and colleagues, and thanks a lot for watching the video.